I'm entering the Labflow now, and I hope everybody in class will follow me, and will then do the same steps I'm performing to do the lab report experiment 4. So a lot of students are asking for the separation of components of a mixture. So we'll do this one here. This is my email, and then I'm entering my password. I'm logging in. Here are the classes. You see a club, survey of chemistry 1 question, and you can see here all the experiments of yours are here posted starting from the schedule of the experiment, practice assignments, lab safety videos, chemistry, math, and lab work videos and quizzes. Lab 2, techniques and measurements. Lab 3, determination of density. Lab 4, that's the lab we'll be working on to get the lab report of it, because I was asked how to get the lab report of this lab, which is a lot of calculation. Lab 5 is types of chemical reaction. Lab 6, modeling geometry and polarity. Lab 7, chemical reaction and equations. Lab 8, empirical formulas. Lab 9, solution, electrolytes and concentration. Lab 10 is Le Chatelier principles. And chemicals. Lab 11, chemicals in everyday life. So lab 12, acid-base titration, buffers, and pH. So nuclear chemistry will not do, but at least there is the whole thing, and the final exam is already posted with its due date. Due date from December 4th to December 5th. So let's go for now lab number 4. Lab number 4 is you will see lab 4, separation of components of a mixture. You will see a couple of those here. As you can see, a couple of files are there with the major theoretical background is the first one, and then two videos or 3 videos here, couple of videos, and then couple of full videos. Then you have a pre-lab quiz, correct? And then you have the report separation of a component. So we are interested in all ways, after looking at all these videos, and take the pre-quiz. It's not graded, just for your own purposes. Some faculty are grading them, but I don't really grade them, just practice them. I go here for taking the snipping tool, take the whole thing here, and then I'll say, okay, this is the first one. And I'll say I'm copy this, and then go to the I am pasting this. So we will need to go through major ones. Let me go for the second one, second snapshot. Let me take this one here, and then the second snapshot will be took those 3. We need to take another 3 here. So let me take another 3 here. New, take another 3. Copying this, pasting into our just lab report. This is not really per se lab report per se, but this is just tell you where to find the stuff and what is really important. So we have this one here, and we will go to the last one, which is very important. So we'll go for the last one. The last one is this one here, which is take new, then I am paste it into this. And so let me take a snapshot of this. Again, new, and sorry, it's not meant, but let me take another snapshot of the whole thing here. Okay, so copy, and I'm pasting the whole thing here. Paste. So now, just to let the students know which all those files are very important for us, is only two. So I'm inserting here. I'm inserting a design. I'm inserting not a design. I'm inserting a shape, just to show you what are those important ones. This is let me take this one here out. Shape filling and shape filling, no fill, and it has to be okay, and it has to be the color will be red. Okay, and we'll take out of this, we'll make an arrow, insert another arrow here. This arrow will show us that the most important stuff is here. This arrow is blue. Fill it. So this is number one. This is number one we have to take care of. This is number one. This is the file we have to look into. And then that's the theoretical background. So this is here, theoretical background. So if I enter a text, so I can enter text here, or enter the text here. I'll say this text maybe will go, try to get this one here. Let me undo it. And so this is the theoretical background here, the first one, PDF separating components and mixture. So this is the background. The next one is, which is the actual experiment. So this is the actual experiment. So let me just insert this one here, and then shape. So here it is, fill, no fill, and it's red, so no fill, and it has to be red. Okay, and the arrow will show us the importance of what is the, let me get to the arrow here, and this is so this is actual experiment online. Experiment is carried out virtually. Okay, so as you can see, and here is the theoretical background. Let me take a space here, and then I will say So here it is. The theoretical background of the experiment. So, okay, so you have two items that you have to follow, and the videos you can read. Those videos you can listen, and you can look at the whole thing. We'll open the PDF just to show you the first one, the theoretical background, and then we'll go for the actual experiment. We'll do the actual experiment in the Labflow. So we'll do the actual experiment in Labflow. Let me just minimize this a little bit so it will minimize this a little bit. Okay, so guys, let's move this one here. Is this one. So now we have two files we have to be concerned or working with, or concerned about. Is the theoretical background. Okay. And this is not the lab report as yet, so I'll take the lab report here out. We'll add it later on, but at least this one here is the procedure or how is we are entering the whole thing. When it comes to the lab floor, lab report, we'll come and do it together. So now let's go and look at the theoretical background file. The theoretical background. So here it is. I'm not, I'm not, it's just I'm not putting all the stuff here. It's a very, transcript here is, this is the, let me go back. Video Benson burner, separating. Okay, let me see, video, the lab separating and report separation of component of a mixture. So we'll go for this. This is the actual background. That's really true. See if it's coming. So this is the actual background. So I can save it and then put it back in so you can see it. So this is all this. I'll download it to this tab. Okay, and I can add it to our, I hope it will. So insert file. Okay, so well, we can go back and look into the take this one down. I'll take this file here, and what I will do with it, open it, and then I will say I will export this one here as Microsoft Word, and then put it inside the so and then I'll select everything here, select all, copying everything here, and then put this one here in the background. So the student then everyone will have the opportunity to look at the theoretical background. So let's paste. I hope it will paste itself. Yes, very good, excellent. So it went very well. So it's pasting itself. So this is the theoretical file background. So this is not the lab report until now, just to show you how the whole thing is processing. So this is the file itself. So Next step is to do the actual work. If you go back all the way up, if you go all the way up here, we have to go to now to the next, which is very important. Report separation of components of a mixture. So we are looking at the report separation of a mixture into its components. So this is another very important part, like the one we had here there, the theoretical background here. So now we have here we'll start here with the report separation of a mixture into its components. So let's go and look to this one here. We can get this one out of our way. So we'll go for the next one. Report separation of a mixture into its components, or separation of a component of a mixture. It's the same thing. So then we'll click on this. Then the next is, so we'll say here, click, go here, click on the icon below. We did the icon here. We said this icon is all about, and the icon is, I think, we can copy it and paste it without going to snipping tool again. I think we can. So this is up. This is the icon here. Copy the whole thing. And this is the icon. This is the icon we are using. So this is the icon we are using. And you can see, well, we can make it even. So then when you have this icon here, maybe this icon is larger, so we can make it smaller. See, I think we can make it smaller than this. New. Hit copy. Go back to our, take this one out. It's too large. Better make it smaller. Yes, that's much more smaller. We click on this icon below. Then click on the report icon on the top banner. On the top, see, on the click on this. Yeah, on the top, you have report here. So on the top of the page. So on the top of the page. The top of the page. So we just show you the whole thing, and take this one here, taking the, just to show the students where is the, so here it is. So edit, copy it there, and here it is. And out of this, we need to show where that really is. Shape our arrows again. This is This time make it red, and then here is blue. So here it is report. Okay, so okay, so this is the report. So I'm clicking on the report. Then I will be asked. So I'm clicking on the report now. So that's what we said. When I click on the report, click on the report icon. So this is very important. In the red. When I'm clicking on the report item here, then I will be prompted to choose what type of experiment I will do it. So I will do it not on campus, I will do it virtually. So I'll use the word virtually. So I come here, it said choose. So I'm choosing what? Not in person, but virtually. So I'm using it virtually. And let me just take a snapshot of this again and say I'm using this one here virtually. Okay. And click next. So edit, copy. Okay, so and click next on the tab. Yes, and click next. Click next. So let me just highlight this one, right? We are clicking next, and next is here. So therefore, let's insert an arrow showing that's really next is. Next is here. Shape, fill, so and click next. So we are clicking on next. And after clicking on next, okay, let's click on next. After clicking on next, then we'll go for the actual experiment. Okay, let's click on the actual experiment, click next. Now we have to enter those data as they are given to us. So I'm entering 39.823. I don't need to add grams, it's already there. The grams is there. So, and then click next. So say enter the mass appears on the balance and click next. So this I'm entering the I'm clicking next. So therefore, you can see me here. You can see here that I have. So here it is. Okay, so here it is. Let me. Okay, so this one here. Let's a snapshot of this. Again, let's see. Next, so 39.823. So here it is. And copy. And I'm pasting this one here. Paste. So click next. Just copy the arrow here. Copy the arrow. Come here to the next part. Then say paste. Take this arrow all the way there. Click next. So, okay, so every time save it. Let's go for the next step. Next step is next. So we are measuring really a crucible empty, 39.823 grams. Next, it says obtain from instructor a sample, right? So we have our unknown number 4. So we have unknown number 4. So we are getting our sample and click next. So it is. Take this one snapshot of this. It says you have to enter the unknown number. This is 4. It's not good. We have to take the arrow out. Okay. So here it is. Okay, so enter the sample unknown number. Okay, so we are entering the unknown sample unknown number. It is, and that would be, and click next, and click next, click next. Okay, so we take this one here, copy this, then paste it, take it all over here. So, okay, good. So next, we are clicking. So this is the crucible with the sample itself is 40 point, with the sample, 40.63635. 4635. Next. Clicking next, we have to take a snapshot of this, enter the now new, and so let's repeat it again. Much better. So yeah, that's much better. So this one here, copy, and we are pasting it. So we'll say we did enter the unknown. Now we are enter the mass of the sample with the crucible. So here it is. We have entered the unknown number, correct? This is enter the mass. Enter the mass of the empty crucibles, which appears in the balance, and click next. So this is empty crucible. This is crucible number 1. This is crucible number 1. So empty crucible. We'll come back to see we need another crucible as well. So we are entering crucible number, which is 40.635. Let me take it another one because it has the problem. It has this, the yeah, let me take picture of it because this one I have to take the arrow out of the mouse. So it is. It should not have the arrow of the mouse here. So free of the mouse arrow. So this is copy. And I'm pasting this one here. I'm pasting this one here. So this is 40, and then click and click next. So we are clicking next and copy the arrow here, copy and paste. Take it from here. Okay, and paste. Okay. So now, remember this is crucible 1. We might need, I think we need to enter the crucible number 2 as well. We'll see. Now, let's see here. Say next. So we did have this one here, the 40.635. Save it, just make sure it's saved. Go back and look at next. Here it is. Now, here it looks after heating, the can look at the values. If we inspect the values here, the value is 40.635 after heating, correct? So now, after, as the procedure says, after heating the unknown sample, okay, number four, so number four, the mass will be reduced to the amount of, enter this amount and then click next. So after hitting the unknown sample, so the mass will be reduced, and this is given here in this will enter it as well, 40.534, 40.534. So 40.54, we get out of this. Okay, take a snapshot of this. You okay, now we have edit copy. I'm copying the this one here. As you can see that the reduced from 40.635 started with to 40.53. So then I have to copy this one here, copy, and then paste it here, paste down here, and then click what next. So here it is. Sort footer. I have to, it looks like for some reason saying up on me. So I will go and close it. I will close this one as well. Now I'll close this one as well. I'll open my lab. See where we're at here. For some reason it went. So okay, so the difference you can see. So here it is. Save the whole thing and next. So click next and see what's going on. Next is we start, I think adding, I can't see it, but we start adding the tabular to solution, and we decanted the salt solution, sodium chloride solution from the sand, and we are heating now the salt. I think I can't see the. No, that's not the salt. I think this is the crucible. This is, I don't see salt inside, but this is the crucible, the second crucible. So this is 35, empty crucible number 2. 2, apologize, 35.7 out of this, and I will say this one here. Now weigh the second crucible. Okay, we weigh the second crucible. After weighing the second crucible, record the mass of it, and then click next. Okay, so let's see here. I'm putting, because it's an empty, 35.277, and I'll take this one here and take the snapshot of the whole thing here. As you see here, copy, and then I'm pasting the whole thing. It's pasted. So this is the second crucible. We'll be using it to separate the sand from sodium chloride to solids by adding tab oil. So tab oil is polar, will dissolve the ionic compound sodium chloride. The sand, and not polar, will be untouched. And then we can decant the solution of sodium chloride and then evaporate each one separately. So we have to copy and paste our arrow here, copy, come here, and then paste it, top, the bottom here. Okay, so this is the second one. Okay, so now then click next. Now we need for the crucible number 2, we need a watch glass. This is the watch glass. So this is 2727 270. So let's take this one here out. Okay, take this one here. Maybe exaggerated, so something like this. Okay, now we have the watch glass, so we want the crucible number 2, and now we are measuring. Now we are weighing the watch glass, which will be used with crucible number, number 2. So crucible number 2 will have the solution of our salt, which is sodium chloride. Okay, so that's the watch glass here. Enter the mass of the watch glass and click next. Okay, so I'm clicking next. So this 27, and let's copy this one here. Copy and paste it here. Down, click next. So okay, so now if you look at the theoretical background, it says if I go back all the way here, just to tell you this, the unknown is made of here our unknown. It is, let me just Labflow did not mention what's this component, but I will mention it here so you can follow me here. The unknown number, and here's the sample unknown is a mixture of ammonium chloride, salt, NaCl, and sand, SiO subscript 2, and ammonium chloride is NH subscript 4, and something Cl. So we have a mixture made of 3 components. Let's see here. Take some out. So this one I just right. Yeah, that's very important to know. You can underline this, but this. So now we know this, the mixture is made of those. So we are now, although in the process of having the watch glass, the second crucible. Okay. Crucible number 2 and watch glass, and we'll hit, we'll hit or click on next. So next. See what they say. So next we are evaporating the salt. So here it is. After adding water to the mixture of the salt and sand, the salt will be dissolved, but the sand will remain untouched. insoluble in water. Then we will decant the salt solution into the second crucible, into the second crucible, and heat gently to drive off the water we had added. The white crystals of the salt will form, and we will keep heating till all water drops are driven away from crucible, salt, and the watch gas cool down the solution. Will cool down the solution and reweigh the crucible with the crucible number 2. So crucible number 2 with the watch. Okay, so this is very important, and then click next. Okay, so it is, guys. This is after heating. This is our salt is there, and the amount is 62.823. So let me take this one out there and copy this. Copy. Pasting this one here. Paste. Okay, so pasting this one here, maybe we have to a little bit. And we have to have copy, paste, take it all the way down. Okay. So okay, hit next. This is, I guess this is maybe the crucible number 1 with the salt. So we put 40.242. 4242. Get out. It does look like a sand, but yeah, that's the sand here. So let me take this one here. Okay, so copy. And now we'll do the same procedure. We will heat crucible number one with the wet sand to dryness. After cooling of crucible one, crucible one, number one, the mass of the sand and crucible number one are recorded. Click next. So this is 40.24. Okay, then copy this one here. Paste it, come and bring it down to here. Okay, now, as you can see, we are approaching to the end of the experiment, so we can start entering the data and go for the calculation. So next, we'll hit next. So we have 40.247, correct? Okay, next. It says you have reached the end. As I said, we have really reached to the end of the assignment. You can review the entries to proceed. The result in the next section will be graded based on the data you have entered above. Once you click proceed, you will be not able to change the data you entered in this section. Well, I think we'll go ahead. This is a demo, just to show you review. This is a demo. And then here it is. Edit, copy. It is now we enter, yeah, we had entered all required data, and we will proceed with the actual calculation, the actual calculations. So here it is. Click on proceed to enter. So it is. And proceed is here. Copy and paste here. Paste here. Okay. So here it is. We are on this one. Save everything. Let's proceed. Okay. Click on proceed. So it is clicking proceed. Okay, I'm clicking proceed. It said errors found. Before you can proceed the next solution, you need to address the following error. The data you have recorded incorrect. Evaluate your measurement. It said that I have entered the mass of your wetting dish and dry sand record exactly as shown in the digital balance. So it shows that we have an error there. So this is good. So it shows that we have an error here. So edit. So it's good that we have entered an error. So an error had occurred, and we have to correct it. So here it is. The error is saying that the error says that we have entered, and this is really good that we have entered an error. And if you can look, it said copy, and we are copying it here. You paste it, take it here. And you know the error came with the blue. So the blue here 6282, we have so this is the blue one here. So let's fix it and see what will happen. Let's see, fix. So when I did fix it, it went to all the way from the beginning. So it does not virtually, so it clean the label. So now it's giving me the whole information that I don't have before. So it said clean up and dry. So I did not have this before. So this is the beginning of that. So I think that's the error came before, because there is, so here it is. Let me take, so the mass of dish one, copy. This is the mass of dish one, which is all the way up. So here it is, which was 39.83. So this one was not seen. So therefore, I will say so it said enter the dish one. We did enter it. Okay. So really it entered this one, 39.823. Okay, next, 39. Then we enter next. Next, obtain your instructor sample, write the unknown number. If you obtain your sample, this is, and this is 4. We did that. So let me see. Next, we have this one here. Enter your sample, which is 4. That's good. So then next, I'm just looking where the error is. And this is very good to know if you did an error. So this is unknown sample 4, and this is mass of dish of the original one. So we don't have this one here. So just a little bit, we did not take the whole thing. So we have to take this one here, copy, and put this one here. Okay, so here it is. So you can see mass of evaporating dish original sample, internal mass of dish 1, crucible number 1, and mass with the crucible 1. This is 40.6, correct? And click, okay, this is correct. Hit next. This is the problem here. Yeah, this one not showing. So now it says we are heating this one here. New. It's too much here. Let me make it smaller here. Okay. Edit. Copy. This is 40 point. 40 point. Okay. So for this, okay. Paste. due to sublimation of ammonium chloride. Okay, so it be reduced. So now it's 40 point. Massive evaporating digital sample. And one is this one here. Just next. Record the evaporating dish 2. This is, they say, the evaporating dish 2. Did not have those. See here. 40, copy. Okay, now weigh the crucible. Okay, so okay, 35 point. Okay. Okay, we did 35.277. We hit next. Mass of the white glass. Copy. Okay. Okay, so match white glass. Okay. Now, this is the problem. Here is saying blue. You can see it is running in blue, so we have to look why it is blue. Yeah, we did not have this. That was jumping there. We did not have this. Now we will have to maybe minimize this so I have it all in one. Okay, so let's get this one here. New. And then from there, we can correct all this. So copy, come here, and paste. So let's measure this. Graduate, carefully balance. Let the evaporating dish cool down in the mass of sodium chloride. So this one here asks for mass of evaporating white glass and dry sodium chloride. You have to make the sum of the three. The sum of the three is 68.83. So the sum of this 68.83. So 68, this is the sum. 68 to 68.823. So 68.283. So mass of evaporating dish 2, glass and dry sodium chloride. So this is the 3168.823. Next. Now, mass of evaporating dish and not including, so copy 62.83, 62.83. Okay, next, 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 next. Okay, so we have this one here, which is, just double check. Okay. Okay, so let me take this one here. Okay, it here now. Okay, this is after that 62.82. This is mass of evaporating dish, glass, and sodium chloride. So this is mass of evaporating dish. Okay, so next, and then next, mass of evaporating dish and dry sand. This is 42.24. C 42.247. 247. Copy. And paste. And here we'll ask us about next. Copy. So here we are. So let's proceed and see if the error fixed or not. I'm not sure what's wrong. 42, proceed. Error found. Before you can open, can proceed to next. The data of recorded in the mass of evaporating dish plus dry sand. Record the mass exactly as is shown in the digital balance. In the digital balance. 27.7, 35.277, 40.534, 40.635, 39.823, 39.823. I'm just checking where is the error set sand with 40.534, 35.2.77, 27.270, evaporating dish, wash glass, and dry 62.823, and here is 40.24. Okay, I see there is 7.247. Okay, so fix. Okay, okay, okay. I see the error. You can see it by 2.27, 35.207, and I can see 8.23. And I fixed the error here, supposed to be 7. Here is 247. So the error is fixed. And I said it is new. And it's good to know. Copy. So then I'll tell you, copy this, paste, and the error inside the 7. So the error inside, insert, shape, error, so and it is the error is found to be at 40.24, 242. So 242. The correct value is 40.247. If we go look at the top of this here, is it here somewhere? 24, 247, 247. Okay. So okay, so now we have to calculate. Now I have all the reports here, and I have to calculate all of this here and enter the data. So I have to enter the data. So let me enter the data here and upload the lab report. So I'm not uploading the lab report now, but I will upload it later on. So now let's see here. First, let's enter all the data we have. So we have mass of a vibrating dish is this. Mass of a vibrating dish and original sample is this. Mass of the sample is this minus this, correct? So it will be, let me see here, take calculator here. So Windows calculator, and then we'll do here the 40.635. You have to be careful about entering those data because the simulation is so sensitive. If you just have an error, one of the digits might not accept it. 39.823, and the answer is, I'm copying results here into this, pasting it. So 0.82. So mass of a vibrating dish after the mass of the sample and after the vibrating dish. Mass of the original sample is 0.812. This minus this. Okay. Mass of the original sample is this. Mass of the dish and the sample after sublimation. After the sublimation. So I will say 40 point. This minus this will give me the amount. How much is this one here? So I'll take this one here. I will say 40.635 minus 40 point 40.534. So 40.635 minus 40.54 equal to, and then this is the sample of this amount of ammonium chloride paste. So then it said percent of mass of ammonium chloride is this one here. So I'm saying this is 0.1, correct? So 0.1 divided by, take this one here now. Trying if see if it will copy all this stuff, but I'm not sure if it will. But at least we can get this copied. Copy. I hope it will allow us to copy. I'm not sure, but might have some block on the copy. Oh, does it? That's good. It does really allow us to copy. So you can see this is right here after entering the whole data into Labflow simulation. So Labflow simulation. So this is, and then mass of this is this one here. It is this is 12 aerial and boat. Okay, so here it is, guys. You can see me here. So this is this. This is this. What I did here, mass of the original sample is this amount here. Copy. This here minus this one here. Copy and paste. So and this one came out to be copy and paste. So 0.02. So mass of a vibrating dish, this one here, from this. So vibrating dish original sample. So will be this one here. Copy it. This one here minus this minus the vibrating dish and the sample is 40.53. Copy and paste. So this one here will be yellow, then equal to equal to copy paste. So you can take this one here out and delete it, but do not delete. So let it just stay. So this one here is 0.100. So percent of the mass will be this one here, this mass of the sample, and this one here will be this. Copy of this, copy, will be this here, paste. 0.101 divided by 0.812 multiplied by 100%. equal to. So let's do this. Let's clean up. So 0.101 divided by 0.812 multiplied by 100. 12.4, three significant figure. 12.44, 12.4, 12.4 percent. So this one here, let me see here. So this one here, 0.18 will be 12.4, 12.4, correct? So just double check, that's 0.108, 0.101 divided by multiply 12 point, multiply by 100 is 12.4, correct? So 12.4%. Now, mass of evaporating dish 2 is this. Mass of the white glass is this. So that's the sum of both. Mass of evaporating dish and mass plus white glass is the sum of both. Is 2,7. Mass of evaporating dish 2 with white glass and sodium chloride is this. So, okay, so mass of sodium chloride is this one here. Copy. This minus both. Correct? Okay, this here. Mass of sodium chloride. Mass of evaporating dish. So mass of sodium chloride will be equal to this one here. Copy. Paste. Then minus evaporating dish minus this one here. Copy. Paste. And then copy this one here and paste. Therefore, here is, so this is minus is 4. So 63 it is. Take our 62.823 62.823 minus 35.277 minus 27.270 equal to, let's copy this one here, copy and paste this one here. So this one here is pasted, 0.276, and I will paste this one here as well. And this is grams. This is grams, okay? So this is grams. This is 0.2276 percent of mass. Well, this percent will be then equal to 0.27 grams of sodium chloride. This here divided by the mass of the sample, as we said, the mass of the sample is 0.8 minus 0.8 0.812 equal, that's gram here, divided by 0.812 grams multiplied by 100% equal to, so 0.812, so 0.812. So take this one here. Let's clean up here. This is 0.276 divided by 0.812 multiplied by 100 equal to 33.9. So this is 33.9. So how much is it? 33.99. So it's really 33.99 and 33.99. And this is this is 0.101 divided by 0.812 multiplied by 100, 12.32, 12.40. So this is 12.40. So this is, let's go here. This is 12.40, and this one here is, how much is it? I think we have it here. This one is the 333, copy it, 33.99. So this is 33.99. So mass of evaporating dish number one, mass of evaporating dish number one, mass of the dry sand is this. So mass of the sand is, let's stay straightforward, that will be 39. So it is okay. So mass of evaporating dish is this one here. Mass of this, mass of the sand equal to 39.823 minus 40 point, that's the opposite, 40.247 grams. So take this one here, cut it, the front here, paste it, minus equal to, so that will be equal to 40 point, not 40 point, 40.247 0.47 minus 39.823 will be equal to this. Okay, this one here now is 0.4, okay, 0.424. How many digits? 3.424. 0.424 grams. Okay, so this one here will be 0.424 grams. So divide this one here. Let me double check. 40 minus 39.823 came out 4.24. So it is 0.424. Mass percentage. The mass percentage will be, take the mass percentage here, point copy of this divided by the whole sample amount, which is the whole sample amount is here. Whole sample amount is 0.812. Point 812. Then multiply by 100% equal to. So let's see here. We have here the calculator. Let's clean up here the calculator. 0.424 divided by 0.8812 multiply by 100 equal to 5222. So 52.22%. So whoops, percent. So this is percent here. And here it is percent. Okay, so this one here will be 52.22%. So this one here will be 52.22 percentage. Now, calculating percentage recovery of the original mass and experimental mass of, okay, so mass of the original mass is 0.812, the original mass, correct? Mass 0.812. Now, experimental mass of this and this and this, we can have to add all those up. We have to add this one here. This is 0.812, and this one here is 52.22, and the mass of the original one is equal to, then we have to add sodium chloride, ammonium chloride, all those together. This is ammonium chloride is mass of a rating dish. Mass of ammonium chloride is 0.101. So this one here is 0.101 gram plus 101 gram. Then point of mass of glass, mass of the sodium, 0.276. Okay, 0.276 grams plus mass of the sand is 0.424 grams. The answer is, let's add them up and see how our experiment is doing, our data. Let's see. We hope we are close to the original one. So let's see, clean up the whole thing. And this really cleaned up here. So we have 0.101 plus 0.276 plus 0.424 equal to 0.801. 0.801. How much is it? 0.801. And so 0.801. Experimental difference with this weighing is, so experimental mass is 0.801. 0.801. We started with 0.02. So 0.001, 0.01, 0.02, 0.01. So let's see, 0.01. So difference here, difference in weighing, this is minus 0.82. So let's take this one here, minus 0.81 will be 0.011. So this one here, so this one here experimental is this. The difference will be this one here, 0.8, 8, how much is it? 812, 812 minus 0.801 equal to grams. But let me just repeat this one again. Clean up 0.812 minus 0.801 be 0.011. 0.011. Okay. 0.011. Recovery mass, mass of the recovered material, mass of the original sample. Recovered sample is mass of the recovered material, which is lab 100. So this one will be, so this one here will be, this one here, 0.801. This one here is 0.011. And recovered will be then, it is material mass. Material mass will be mass of the recovered sample. Mass of the recovered sample is 0.08. Recovered sample, how much? Is 0.801 divided by 0.812, correct, 12, multiply by 100% equal to, so let's see, this one here, 0.801 divided by 0.812 multiply by 100 equal to 98.65. So this one here, 98.665. 65%. So this one here, 98.65. So this one here, 98.65%. So let me 0.801, just double check it. Point here, 0.081. Yes. Okay. So it will be 98.65 will be 98.65. 65 is it 65? 65, yes. 98.65. So this is 98.65. So select a reasonable explanation to account of the difference based on your data results. It might be more than one possible reason that makes sense, but just select one of them. So it is possible not all the water was evaporated. That's not the case. We get 98. It is possible not all of the water was evaporated. While drying, sodium liquid boiled and some splattered dish causing experimental mass to be lower. So this is C. While drying sodium chloride, the liquid boiled, some out of evaporating, causing C or D. So this one will be calculation, upload images. Okay, we'll do that later on. Submit. Okay, submit. Let me see the data. Submit. See what the data will come up with. If I have done a good job, it will be with the circles. Yes, the data came out very, very beautifully done. And all the circles are here. So what I'm going to do is taking all the data are correct. So I'm not doing the lab report now. I'm collecting just the data. So the data will start. Let me just take this one here. So this is from here. So I'm collecting. This is my data. I'm not. So taking all this data, correct? So this is the data. So here it is. That's the first one. Take this one here. Perfect, perfect, perfect data. I'll be using them for my lab report later on. I'll make the lab report and I'll send it to you. But at least you know this is beautiful data. Choose this is C. So this is C here, and the data here. The data are data are entered, and the results are obtained with green circles, which means which mean which means that my results obtained are correct, and hence my calculations, all my calculations, here it is, all my calculations are correct, which means this means green circle. So let's do this one here, the first one, and this is the first one. That's the first green one. First set. Let's go for the second set. It took time, but it's really worth it to do it. So we did this one here, the 4, correct? Now number 3. Number 3 here. Okay. Take number 3 and take number 3 here, and I need the data with the green. With the green means tells me if my calculation is correct or wrong. If I get the red circles, means my calculations are not correct. So this is good. Let's go for the second one, or the third one. Third one. So we did this one here. The third one here. Okay. And let's take this one here. Silicon dioxide. Copy and paste. X and copy and paste the other one. 11. Yeah, we did cover this one here. Yeah. Okay, so let's see here. And I'm taking this one here, copying this one here all the way. Okay. Sorry about this. I have to go back and okay, so new. Copy, paste it here. I hope it will no problem. So well, we have this problem here. I don't know why. So let's see if I can get rid of this. Okay, so let's see. Okay, so let's see if I can get this one out of our way. Yes, this is good. Copy. I'm pasting this one here. Paste. Okay. After that will be after the 5 points. Almost there, almost there, almost there. 5 points we have selected. And this one here. Copy this. Copy. Paste. That's all the data we have. I did not upload any images or any calculations, or all the calculations are shown in the file, and the lab report should be done. And with added the circles here, the data with the green circles means calculations correct. We'll add it in the section of the lab report called data and results. So you have to have in your lab report, you have to have 5 components: introduction, procedure, data, and results. That's what the data, capital, and base it from your obtained data from Labflow, and then discuss your data. So your recovery is good, your data are good. So you are set to go to have very good lab report. And then conclusion, which you go to your objective and goals of the experiment to begin with. Thank you very, very much. And I think that's covered the whole thing. Thank you very, very much. Thank you.